Hello friends, in this video we are going to solve a question of theory of computation which is also helpful in your GATE exam. Let's see, it is our question number 6 and we have to choose the correct statement. First statement we have all languages can be generated by CFG, that is context free grammar. Second we have any regular language has an equivalent CFG. Some non-regular languages can't be generated by any CFG. And D, some regular languages can't be generated by and CFG. It's any, sorry for the mistake. Let's analyze each statement. What we have: A, all languages can be generated by any CFG. This statement is false. There exist languages such as language of all palindromes which cannot be generated by a context-free grammar (CFG). So statement A is incorrect. B, any regular language has an equivalent CFG. This statement is true. Regular language are a subset of the languages generated by context-free grammars. Every regular language can be generated by a regular grammar which is of type CFG. Therefore, statement B is correct. C, some non-regular languages can't be generated by any CFG. This statement is true. There are some non-regular languages such as the language of balanced parentheses that cannot be generated by any CFG. Fine. Therefore, statement C is also correct. We have statement number 4, that is some regular languages can't be generated by any CFG. So this statement is false because every regular language can be generated by a regular grammar, which is a type of context-free grammar. Therefore, statement D is also incorrect. So the correct statements are: we have B, any regular language has an equivalent CFG, and C, some regular languages can't generated by any CFG. Let's move to next question. This is our question number 7. Which of the following CFG can't be simulated by an FSM? First we have S gives SAA. Second we have S gives ABX, where X is CY and Y is D and AX. C, we have S gives ASB and AB, and D gives none of the above. Let's see them. To determine which of the following context-free grammars can't be simulated by a finite state machine, we need to identify CFGs that have non-regular languages. Finite state machine can only recognize regular languages. So any CFG generating a non-regular language cannot be simulated by an FSM, that is finite state machine. Let's analyze each CFG. We have A. S gives S, A and A. This CFG generates a language of strings consisting of one or more A's. So since this language is regular, it can be simulated by an FSM. FSM is finite state and machine. Fine. Second we have B. S gives A, B, X, where X is CY and Y is D and AX. So this CFG generates strings of the form ABCD or AABCD. This language is regular, so it can be simulated by an FSM. Third option we have S gives A, S, B and AB. So this CFG generates a string where A's are followed by the same number of B's. This language is not regular. It's the classic example of non-regular language, as it requires counting, which cannot be done by an FSM. Therefore, this CFG can't be simulated by an FSM. And D, none of the above. If none of the CFGs generate non-regular languages, then option D would be correct. However, as identified above, option C generates a non-regular language. So, the correct answer is C, which is S gives A, S, B and AB. This CFG can't be simulated by an FSM because it generates a non-regular language. Thank you.